Hi guys, welcome to another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you're looking for elsewhere. There's a lot of information out there. Be aware that I'm not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today we're going over 10.1, area of triangles. We're going to talk a lot about how to identify bases and heights of triangles, and then we're going to go into how to use the formula for area of a triangle to find area, the base, or the height of a triangle given specific information. So we've got a couple vocab terms to go over. The first one is base. The base of a triangle can be any of the three sides of a triangle. So any of the three sides can be a triangle. So if I look at these, that could be the base, that side could be the base, or this side could be the base. It has to be tangible, meaning you have to be able to touch it. It cannot be imaginary. So any of the three sides can be a base. Next, height. Height is a little bit more complex. Height is the distance that is perpendicular to the base to the opposite vertex very important. It forms a right angle with the base. So your height depends on the base that you choose of your triangle. It must form a right angle with the base. Has to. So essentially, you're looking for a perfect 90-degree angle. That right there, a 90-degree angle. Whether it's given to you like this, oh, I see a 90-degree angle right there, or if you use straight edges to make one. So I can make an actual 90-degree angle with a couple straight edges. Otherwise, you don't have yourself a height. All right, next, the formula for area of a triangle. There's a couple or a few different variations. The ones I like are A equals 1/2 BH. You could also use decimal instead of a fraction. So you could use A equals 0.5 or 5/10 BH. You could also use A equals BH divided by 2. I don't particularly care for that one. However, it is legitimate formula. What does this stand for? Well, first, A stands for area. The B, little b, stands for base of a triangle. And little h stands for height. Make sure you keep the capitalization like that, because when we get into volume, we're going to have capital B. It stands for something else. Okay, so if we put this all together, essentially it means area of a triangle is equal to 1/2 times or multiplied by the base times or multiplied by the height of a triangle. And again, the base can be any of the three sides, and the height has to be the perpendicular distance to that base. All right, so first, before we can start using formulas, we have to be able to identify a base and height of a triangle. You might be like, oh, it should be easy. No, not actually. A lot of people have difficulty finding the height, for example, of a triangle. So we're going to start by looking at the easy ones. We're going to identify a base and height of a right triangle. It is only a right triangle if there is a right angle. So if you see this marking right here, you have yourself a right angle. If you don't see that symbol, you don't have a right angle. Never assume that it is a right angle. For example, I could look at this triangle. That looks like it almost could be a right angle a little bit, but it's not. It's actually an obtuse angle. Don't assume based on looks. So you have to see one of those, or it's not a right angle. Okay, now these are the easy triangles because they already have a 90-degree angle. And again, those 90-degree angles form a base and height. So we're going to go over all possible combinations of identifying bases and heights. All right, our first one. So let's look at this one. I see a right angle right there. So that means one of those sides can be my base, and the perpendicular line to it, to the opposite vertex, that essentially means to the opposite point, is going to be your height. So I could label from B to C as my base. If that's my base, what forms a right angle with it? This line right here. The one that is going perpendicular from here to the opposite point. So line AB would be my height. Again, they form this right angle, and if you look, that right angle kind of looks like an H. So essentially, you could use that as, oh, if I see the H, I've got myself a height. Okay, now that's one way to label them. How would you identify them? You could write line BC equals, what does it equal? It equals my base. So the little b. So whatever that is, that would be your base. What is my height that goes with it? Line AB or BA. Order doesn't matter on these line segments. And that would be my height. So we've labeled and identified. So depending on what your question asked, that's how you do it. Okay, so we said the base could be any of the three sides. So what if I chose this side to be my base from A to B? Well, I could label it like that. Now, what line forms a right angle with it? Well, I see right there. That's my right angle. I could use a ruler or two straight edges to show that, oh, see, it makes a nice right angle, 90-degree angle with it. So if this is my base, this is the height. This is how tall my triangle is. So we've labeled it. How would you identify it? I could say line AB equals my base. In this situation, line BC would be my height. So in this example, this was the bottom or my base of my triangle, meaning this would be my height. In this example, I said this is the bottom or the base of my triangle, meaning this would be the height. It's the line that is perpendicular to it. What if I chose this to be my base? So I'm going to turn it so it just looks normal. So I want to make this my base. I'm going to write it out since I'm doing it upside down. What do? Well, I need a line that's going perpendicular to it. Is this line going perpendicular to it? No, that does not form a right angle. That looks ridiculous. So I would put two straight edges flush or flat against each other, and it needs to go to the tip top of the triangle. So if this is the bottom of the triangle or the base, what would the tip top be? B. Heights can't be slanted. They must form a right angle. So I would move this straight edge flat against the bottom until it touches the tip top of the triangle. So right there, and I would have to draw in my height. So essentially, I formed the right angle. So this is my height. And I created an imaginary new point. So that's point A, point B, point C. I need to be able to identify that point, so I'm just going to label it as point X. So if this is the bottom of the triangle, that means that's how tall it is, not this line. This line does not form a right angle with this line. So how would I identify them? I would write, so if this is my base, A to C, I would write line AC equals my base. This is my height. That's perpendicular to this line. So line BX, that's why I needed the imaginary point. So line BX is my height. Again, they must form right angles, bases and heights. So if this is my base, this cannot be my height. That can't be my height. You have to draw in your height. Here, I did not have to draw in my height because those two lines and those two lines already formed a right angle. Okay, those are the easy ones. What if you have non-right triangles? What does that mean? That means you have a bunch of triangles and they don't have right angles anywhere in them. So that makes things a little bit more complicated. So this is how you identify them. First, figure out which side do you want to be a base. So let's look at triangle DEF. Well, they're all DEF. The first DEF. I want this side to be my base. So I'm going to label this side as my base. I'm going to put my ruler flat up against it. And I'm going to put my other ruler flush against it. So would line EF be my base? No, that does not form a right angle. The ruler must stay flat or your straight edge, and it must touch the tip top of the triangle, which would be point E. So if this is the bottom, that would be the top. So a perpendicular line would have to be drawn in right here. So right there, we created a new imaginary point called X, which is why I wrote my B a little below there. And this is my height from E to X. D to F is my base. So let's write that out. Line D to F is my base, and line EX is my height. Those form a right angle. So notice my height was not any side of the triangle. All right, next, what if I wanted this to be my base, or what if a problem gave this as my base? So let's do that next. I'm going to turn it so it looks right. So I'm going to label this as my base. Put my ruler flush against it. What's the tip top of the triangle? If this is the bottom, point F is going to be the tip top. So take the other straight edge you may have, flat against it until it touches the tip top. So right there, I'm going to draw in my height. Let's go ahead and add a bottom right there. Okay, so I had to draw an imaginary line on the outside. This is going to be called point X. If this is my base from E to D, again, this can't be your base right here. Like, imagine if you're, standing and walking, well, you'd fall like right through. You'd die. So that is not going to be your base. Not part of the base. Bases have to be tangible. They have to be solid. Okay. So the base is from E to D. That means this right here would be my height. The height can be imaginary because your height is essentially just saying, how tall is it? Well, this is going to be how tall it is. Okay, let's label it. Line ED is my base. That means line FX is my height. Again, notice I had to draw the height. There wasn't a single side of that triangle. That was my height. All right, last one. So we chose this side to be our base. We've chosen this side to be our base. Let's choose this side to be our base. So I'm going to turn it around. I'm going to label this as my base. So put one straight edge on it. What would the tip top of the triangle be? Well, in this case, D would be the tip top of the triangle. So I'm going to take my other straight edge and move it flat until it touches the tip top right there. Oop. So I can draw in my height. Remember, the base only goes from here to here. We're going to call this imaginary point X. And this right here from D to X is my height. All right, let's write how we would identify it. We're going to say line EF is our base. And what line is perpendicular to it? Line DX. So line DX is our height. So what do we notice on all three of these examples? There wasn't a single side of a triangle that was our height. Why is that important? Well, if you're working out an example and it gives you, let's see, this number right here, let's just pretend that's 10. Let's say this number is 11, and it gives you this number right here, which is, I don't know, let's just pretend it's 8. These are just made up numbers. Well, which numbers would you use? Well, for my formula, I need a base and a height to find the area, right? Well, would I use 10 and 11 or 10 and 8 or 11 and 8? You've got to be able to identify a base and height. So in this case, this is the only solid side I'm given, so I have to use 10 as my base. 11 is not perpendicular to that. 8 is. So my height would be 8. So for my formula, I would have to use 10 and 8. 11 is a trick number trying to mess you up, seeing if, do you know what a base and height is of a triangle? So that's why we need to be able to identify bases and heights. Otherwise, you end up using the trick numbers or the wrong dimensions to find an area. Okay, let's move on. We've got 3 more examples. So we've got triangle GJH. So first, let's use line GJ as our base because, you know, it's right there on the bottom. So we're going to call that our base or label it like that. What's the tip top of the triangle? H. So I'm going to use another straight edge, put it flat against that ruler, and go until it touches the top right there. I'm going to draw in my height right there, all the way from the bottom to the tip top. So again, remember, the base is only from there to there. This imaginary point we're going to call X, and this line right here, the imaginary line, that is our height. We're saying the triangle is this tall from here to here, straight up and down, not slanted. Okay, let's write our labeling, or sorry, our identification. Line GJ is our base, and line XH or HX, let's just write HX, keep it consistent, is our height. So we've labeled and identified. Okay, let's do another practice problem. I've chosen that to be my base. Let's do this side as my base, because any side of a triangle can be a base. So I'm going to put one straight edge on that base of my choosing. What would the tip top of the triangle be? G, right there. So other straight edge, flat. Move it until it touches the top. Might be easier if I come from the side. So from here to here is my base. This imaginary line from G to point X, we're going to call it, is our height. All right, let's write our identifying letters. Line JH is our base. If that's the base, then the perpendicular line to it is line GX. So line GX is our height. Last example. So I've chosen that to be my base, that to be my base. I have not chosen that to be my base. So if that's my base, put a straight edge on it. What's the tip top of the triangle? J. So move your straight edge until it touches right there. Or come in from the other side. So this would be our height. Notice on two of the triangles, we drew the height on the outside of the triangle. If I choose this side to be my base, the height goes on the inside. That's typically easier to do if all you're doing, or if your only objective, is to identify a base and height. That's typically the easier way to do it. Find the one on the inside. Okay, let's identify it. Line GH is my base, and line, oh, I forgot to put my imaginary point, X. Line JX is our height. So let's look at all 6 of these random examples. The heights were not part of any of those triangles. So if you have a non-right triangle, the height must be drawn. It will not be part of the triangle. Only the base will. If you have a right triangle, part of the triangle could be the height because it forms a right angle. All right. Hopefully, we can identify some bases and heights. So now we're going to apply that to actually finding area, base, or height of a triangle mathematically. So our first example, we're going to find the area of a triangle. In triangle ABC, line AX, this imaginary line, it's perpendicular to line BC. See, a little right angle right there. So that means this is our height. And what forms a right angle with it? Line BC. So this is our base. This distance has been drawn over here. So they're saying our height is 14 and our base is 10. It's important to note, again, any side of the triangle can be called the base. The height of the triangle, however, has to be perpendicular from that base to the opposite vertex. So perpendicular line from it to the opposite vertex, point meaning. All right, so how do you use a formula? How do you find the area? Well, first, always start with the formula that fits the shape. So this is a triangle. It's talking about area. It's got bases. It's got heights. So our formula is A equals 1/2 BH. Next step, substitute what you know. So what do I know? Do I know the area? No, that's what I'm trying to solve. So I'm going to leave that as an A. Equals, leave that as 1/2. B, do I know the base? Yes, the base is 10. So replace B with 10. Do I know the height? Well, if I have to know the area, or I need to find the area, I have to know all of the other letters. So they will have to give me the base, and they will have to give me the height. Otherwise, I can't find A. So height is 14. All right. After you have substituted and replaced all but one letter of your formula, you can then solve for that letter. So A equals, I can combine and do stuff like 1/2 times 10 is 5. Bring down our 14. Next step, A equals, what's 5 times 14? 70. And then I need a label. What is area all about? Area is essentially how many squares of a specific size will cover a shape. So we're saying 70 squares, the size of a centimeter, will cover this shape. So I would write 70 centimeters, because that's the label they're using, to the power of 2. So our answer is A equals 70 centimeters squared. We're saying 70 centimeter size squares will cover that triangle. So please remember, area is always square units. You are determining how many squares will cover a surface. Kind of like if you want to buy tiles to cover your kitchen floor, or you want to buy carpet, or you want to buy paint to cover your walls. You essentially want to know how many squares can you cover the surface with. And that tells you how many tiles you need to buy, how much carpet you need to buy, and so on. A note about this, you can use a calculator as long as you're showing your steps, because, most math teachers, want you to show your work. All right, next. In triangle PQR, line PX is perpendicular to line QR. So QR is going to be our base, because it's the only side of the triangle I have. What is my height? Is it this line or this line? Well, note, PR is not your height. Why? Because it doesn't form a right angle. I could use straight edges to prove it. See, that's not a right angle. It looks ridiculous. That is a right angle. So line PX is our height because it's perpendicular to this line. It is imaginary though. We're just saying it's that tall. So if you had a number here and a number here, make sure you use this number and not this number. It would be a trick. Okay, first step, I want to find area. So I use what formula? Not any formula. Don't use A equals LW, for example. That's only for squares or rectangles. This is a triangle. So we use A equals 1/2 BH. Next step, substitute what you know. Do I know A? No, I don't know the area. I'm trying to find it. So A equals, what do I do with the 1/2? Write it down again. What do I do with the B? Replace it with the base. The base is 30. Do I know the height? Well, I have to know the height if I want to know the A. You have to be able to fill in all but one letter. So what's the height? That'd be 25. Next step, solve step by step. So 1/2 times 30, we can do that mentally. That would be 15. Now bring down your 25. Area equals, what's 15 times 25? No idea. We get 375. 375 what? Exactly. Feet squared. That means this triangle in real life can be covered in 375 feet, squares the size of a foot. So that is our answer. Again, remember, area is always square units. Area is all about how many squares cover a surface. Those are horrible squares. Don't judge. Okay. We have 2 more examples, but we're going to change it up a bit. This time, we're going to find the height of a triangle, and we are going to be given the area and the base. So they're going to tell us the area. They're going to tell us the base. We have to find the height. Okay, the area of triangle FGH is 46 square inches. So voila, we're not going to find the area. They gave it to us. Now we're going to find the height. Okay, so what do? Well, we use the appropriate formula. This is a triangle. It talks about area, base, and height. So I'm going to use A equals 1/2 BH. Don't use any other formula because it's a triangle. You have to use triangle formula. Okay, next, fill in what you know. Do I know A? Yes, you do. Area is 46, so replace the A with a 46. Equals, what do I do with the 1/2? Just write 1/2. You can't do anything with it. It's a half. Okay, B, do I know the base? Well, if I'm going to find the height, I have to know the B. Again, you have to know all of your letters except for one. So, what's my base? The base is line GH, so 11.5. What do I do with the H? You leave it. You don't know it. So instead of solving for A, I'm going to solve for H. Again, note, since we don't know the height, we leave it as a variable. All right, next, what do I do now? Simplify, combine like terms, do whatever you can, do what can be done. So I can't do anything with 46. Equals, can I do anything over here? This is essentially saying 1/2 times 11.5 times h, or 1/2 times 11.5 h's. So if you had 11.5 h's and you want half of them, how many do you have? So we're going to multiply what can be done. So 1/2, or 0.5, times 11.5, that messed up, there we go, we get 5 3/4, or 5.75. We're not finished. Bring down your h. So 1/2 times 11.5h is 5.75h. What do we have? We now have a one-step equation, meaning one step and you're finished. And solve by balancing. So, in previous videos, I drew lines down the equal signs. You can still do that. I'm not going to for this example. So I want to get h by itself. What needs to go away? The 5.75. What are they doing? They are multiplying because that letter is shoved up right behind that number. They're together. That means multiply. So what's the opposite? Division. So I'm going to divide by 5.75, and I'm going to do it to both sides of the equal sign. The right side, those cancel, leaving you with h equals left side. What's 46 divided by 5.75? 8. 8 what? This is height, not area. We're not talking about how many squares will cover a surface. We're just talking about how long something is. So this would be inches, not squared, just inches. So again, our height is equal to 8 inches. So let's note that the height measures a straight line, so its units are not squared. We're not finding area. You're not finding out how many squares will cover a surface. All right, we have one more example. Essentially the same, but this time we're going to find the base, and we're going to be given the area again and the height. So we're just swapping out letters. So instead of solving for h, we're going to solve for the b. Okay, same setup. It talks about triangles. You're probably going to use a triangle formula. I mean, it'd be weird if you used a square formula, right? Okay, the area of triangle XYZ is 36.5 square centimeters. Find the base. So first step, write your formula. A equals 1/2 BH. Next, fill in what you know. Do you know A? Yes, area is 36.5. So replace the A with 36.5. Equals, what do I do with 1/2? It's just 1/2. Write it down. B, do I know the base? Nope, there's a big question mark right there. I don't know how big the bottom is. So leave it as B. Do I know the height? I have to know the height because you have to know all but one letter. So what's my height? 10. Again, be careful. If they give you other numbers, don't be fooled. I must use this one because it forms the right angle. See that right angle right there? That means you have to use this as your height. So if they give you this number, let's pretend, I don't know, it's 12. It's completely bogus. But let's pretend they give you 12. Don't use it. It's a trick. The height has to go straight up and down. So use 10. Okay. You can solve this just like this. Or if it makes you uncomfortable with that letter being in the middle, I don't know why you'd be uncomfortable. Like, it's weird. It's just a letter in the middle. You could, because multiplication is commutative, meaning you can multiply in whatever order you please, you can switch these, rearrange them, if that makes you feel more comfortable. So just going to note, you can switch terms if needed. Just on this. Why? Because multiplication can be done in whatever order. So I'm going to do that. 36.5 equals, instead of 1/2 BH, I'm going to write 1/2 times 10 times B. Again, not necessary. I can take 1/2 times 10 just as easily as doing it right here, which is what I'm going to do next. 36.5 equals, what's 1/2 times 10? 5. Bring down your B. So half of a B times 10, or 1/2 10B, is still going to be 5B. Okay, I now have a one-step equation. I need to get B by itself. It's being multiplied by 5, so the opposite is divide by 5 on both sides. Those cancel, leaving us with B. 36.5 divided by 5. Is 7.3. 7.3 what? I'm finding a distance. I'm finding how big the base is. It will be simply centimeters. That's a horrible M. There. So our base is equal to 7.3 centimeters. Again, the base measures a straight line so its units are not squared. We're not finding out how many squares will cover a surface. We're not finding area. Now, real quick, what would this look like if I didn't switch it? It's nothing big. So I would have 36.5 equals 1/2 B times 10. Then I'd have 36.5 equals, what's 1/2 times b times 10? Well, I just multiply what can be multiplied, so 1/2 times 10 is 5. Just bring down your b. It's no difference. It actually takes less work to do this, but for some reason, a letter being smushed between numbers freaks some people out. So you can switch terms like that if needed. And then, of course, divide by 5 on both sides, and you get the same answer, b equals 7.3 centimeters. Okay, I hope this has helped with you being able to identify bases and heights and using an area formula for triangles to find not only the base, a height, as well as area of triangles. If it has not helped, I hope you can find what you're looking for elsewhere. Y'all have a great day.